Visible to you?
Yes, sir.
Okay. Now go to the Google Chrome and type vlabs.iit Kharagpur vlab IIT K this one vlabs.iitkgp.ac.in. Select electronics, or basic electronics. Now see the list of experiments. Yes, any doubt in V characteristics of diode? Say yes or no. Any doubt in VA characteristics of a diode?
No, sir.
No. Okay. Now we want half a rectifier, na? Half a rectifier, full wave rectifier, and capacitive rectification. Yes or no? So in half a rectifier, so for the simulation, half a rectifier. So here you have to change the load resistance. He has given the instruction, set the load resistance RL. Click on button to start the experiment. Double click on sine wave button to generate the input waveform. Click on oscilloscope button to get the rectified output. Vary the amplitude, frequency, and volts per division using the controllers. Just on this one. Now select the resistance value. Why it is not activating? Connect the components as mentioned below, L1 to L7, L1 to L7. Next L3 to L7, L4 to L5, next L5 to L8, L12 to L16, L12 to L16, sorry, L6, L8 to L9. Click on check connections. So right connection, no problem. Tell the resistance RL. You can change the RL value, whatever you require. So here I'm keeping at 1 kilo ohm. Now double click on this. I'll click on this. Click on sine wave. Oscilloscope. Channel 1 input signal. Channel 2 output signal. Suppose you are selecting the dual channel input as well as output. Both are appearing here. If you want to observe, you can change the position of either input or output. Suppose we want to change the number of cycles per second, change the frequency. That's it. If you are changing the frequency, then automatically the amplitude also changes. So this is the input signal, this one, and this one is output signal. Now in this any doubt? So like this you have to display the output as well as now we have to calculate this one. VRMS equal Vm by 2. So for output, what is Vm value? Vm by 2. Vm is the peak voltage, this one. VDC equal Vm by 5. A ripple factor VAC by VDC. Now VAC equals square root of VRMS square minus VDC square. So this is AC. Already we have calculated VRMS VDC. From this you can calculate VAC. So ripple factor is equal VAC by VDC. Like this you have to calculate. Now any doubt in this? Dear students, please respond. Dear students, please respond, ma. Go.
No, sir.
Yes.
No, sir.
In this, any doubt, boys and girls?
No, sir.
Uh, okay. Next, similarly, we go for full wave rectifier. So full wave rectifier means here bridge rectifier only. Same by observing the instruction, you can connect the circuit. Connect the circuit parallel with me. So L1 to L7. All of you connect this one. L4 to L7. L1 to L7. L4 to L7. Next, L12 to L5. On connection. Yeah. Next L12 to L11. Next L8 to L9. L6 to L10. L3 to L11. L10 to L8. Now check the connections. Right connection. Now click on check connection. Now set the resistance RL. So this one is input signal and this is output signal. So here the resistance is not valid. Yes, have you completed this one, ma?
Yes,
Yes,
sir.
yes. Have you completed connections and
Yes,
have
sir.
got this output waveforms?
Yes,
Any doubt
sir.
in this? Same here also we had to calculate VDC,
Yes,
VRMS
sir.
as well as ripple factors. So by observing this one, you can find the what is VM value. Yes, this is 1 unit. So 1 unit value is equal to how much? He has given here 1 volt per division. 1 unit is equal to 1 volt. Now, dear students, boys and girls, any doubt in this?
No,
Shall we
sir.
move to the next experiment? Girls are not responding.
Yes, sir.
Yes, sir.
Sir,
Yes, tell me, ma.
మనము వాల్యూస్ క్యాలిక్యులేట్ చేసి అది పేపర్ మీద రాసి మీకు పెట్టాలా సార్?
1 minute నేను చెప్తాను. నేను చెప్తాను మీకు ఎలా చేయాలనేది.
ఓకే సార్.
Only 50 students are there. What about 10 students? They are perfect. So now we'll see the capacitor rectification. So here two experiments are there: capacitor rectification for half-wave rectifier as well as full-wave rectifier. So it's very simple. The resistor as well as capacitor are already fixed. So connect AC source voltage already connected. Click on button. Click on sine wave. Click on run simulation. Observe the corresponding waveform. So this is the rectified output. This is the half-wave rectifier. So channel 1 shows the half-wave rectifier output. This one. This half-wave rectifier output is given to this capacitor filter. Then you are getting the capacitor filter output is this one. So if you want to observe both the signals at the same time, that is half-wave rectified output without filter as well as half-wave rectified filter with filter, then go for dual mode. So this is without filter and this one is with filter. That's it. Same, we have to calculate these values. Suppose if you want to change the input voltage like this. It is 1 volt only, but you are changing the volts for division. That's it. You are magnifying or reducing the signal. Not reducing, you are just magnifying the signal. But amplitude is constant. Similarly, capacitive rectification with full wave rectifier. Same procedure. Here, the capacitor resistor value is already fixed here. Just you have to on the circuit. Full wave rectifier output. Run simulation. So this is channel 1, full wave rectifier output. Channel 2 with filter. If you want to observe both without filter and with filter, this one, dual mode. So here we don't have print option. So when there is no print option, yes, here print option is there. Suppose when there is no print option, what you have to do? Yes?
PRTSC, sir.
Yes, print screen. If you are pressing that button, then the total window will be appear. Now change that into or save that as PDF format. And all the images should be saved as JPEG format. JPG. Next. Now Gina diode. So in Gina diode, we have to do two experiments. Gina diode with load regulation and Gina diode with wave characteristics. Are you getting this? GNR diode with not line regulation, GNR diode load regulation, and GNR diode characteristics. So GNR diode load regulation drawing. We'll see that. Now connect the circuit by observing these instructions L1 to L3, L4 to L7. Connect chain faster. L1 to L3, L7 to L4, L8 to L15, L15 to L10, L11 to L17, L16 to L18, L17 to L5, L18 to L6, L13 to L15, L14 to L19, L9 to L16, L12 to L9, L12 to L9, ground. Now check the connection, whether the connections are correct or wrong. Right connection, no problem. Now set DC voltage to 6 volts. DC voltage to 6 volts, VDC. Where is VDC? Here. So to change this, the VDC reading will be changes. Keep it as 6 volts. Set the series resistance RS to 100 ohm. Series resistance RS to 100 ohm, this one. This is 100 ohm. And set the GNR voltage VJ to 5.1. GNR voltage here, it is appearing here, 5.1. And vary the load resistance RL. Now by changing load resistance, that output voltage also changes. So this one, load resistance, load resistance. Now add to table. Now change the load resistance. If changing the load resistance, IZ will vary, IL will vary. In the morning, we have seen that problems while doing the GNR diode problems. Now for the graph. So he has given the graph output voltage and load resistance RL. Yes, any doubt in this? Yes, students.
No, sir.
Any doubt in this?
No, sir.
Okay. Similarly, go for the Gina diode characteristics. So directly he has given the demo here. So select the diode here, any one diode. Here Gina diode. ZD means Gina diode. So set restart at RF equal 1 ohm. By adjusting the restart, voltmeter reading is increased from in each time. Note the corresponding readings in millimeter, milliammeter. Take the readings and note down the voltmeter reading at the Gina diode and ammeter readings. Plot VA graphs. Note, note down the values here. Change this resistance value and note down the values. That's it. These are the VA characteristics. So we have to take more number of values, then you will get the smooth waveform. Means call this now. Huh?
అదే డేటా ఎవరెవరు వ్యాక్సినేట్ చేస్తున్నారో వ్యాక్సిన్ వేయించుకోలేదు ఆ డేటా అంతా నాకు ఫుల్ మండే కంతా పంపించుకొని చెప్పారు.
Just any doubt in this, ma?
ఈరోజు నైట్ కాల్ చేశాను.
No, sir.
So these are the Gina diode characteristics. Next one. Also the BJT. Now here in BJT, so up to now how many experiments completed? In VA characteristic, the forward bias as well reverse bias 2 experiments, half wave rectifier, third, and full wave rectifier 4, half wave rectifier with capacitive filter 5, full wave rectifier with capacitive filter 6. Next, Gina diode, load regulation as well as VA characteristics, 8 experiments completed. Now, in BJT common emitter characteristics, we have to take 2 experiments. One experiment is input characteristics. We have done the experiment for both input as well as output characteristics. But here, we have divided that into 2 experiments. One is input characteristics, other one is output characteristics. So, there are total 10 experiments. Are you getting this one, ma? Yes, dear students?
Yes, sir.
Yesterday, I have given
Sir.
total 9 experiments, but here I have splitted this 9th experiment, that is C configuration, into 2 experiments. One experiment is input characteristics and the second one is output characteristics. Now we'll see that. So BJT input characteristics. We have already the procedure in observation book as well as record. So what is the input characteristics? We have to fix the output voltage and we have to change the input voltage and we have to find the we have to draw the graph between VBE and IB. Yes or no? See this? Initially set RH1 to 1 ohm. Next, set the collector emitter voltage VCE to 1 volt by adjusting resistor 2. So this RH1, this resistor is to vary this voltage, input voltage, and RH2 is to vary the VCE voltage, yeah, collector to emitter voltage. So by changing the VCE to VCE, sorry, the RH2 resistance, we have to keep VCE at 1 volt by. So this is the VCE. So if you are change up to it is 1 volt. So now here VCE is 1 volt. Now we are fixed that one VCE. Now we have to vary this VBE as well as, so when you are varying this RH1, then VBE changes as well as IB also changes. See this ma? Now base emitter voltage VB is varied by adjusting the RH1. Now readings of base current is in microamperes. See this ma? So if you are changing RH1, VB changes. First take this one table. Next, change the RH1, VB changes as well as IB also changes. Now plot the graph. So this is the graph between base emitter voltage VB and base current IB. Now any doubt in this?
No, sir.
Now similarly, one more experiment is BJT output characteristics. In output characteristics, now we have to keep input. What is the procedure? Set RH1 to 1 ohm and RH2 is also 1 ohm. Next, set the base current IB at 15 microamperes by adjusting the resistor 1. So when you are changing this RH1, the base current is also changes. So you have to keep at 15 how much it is? 15 microamperes. Now change the RH1 such that the IB is equal to 15 microamperes. Now you are fixing this one. IB is fixed. Input current is fixed. So take approximately 15 microamperes. Now we have to change RH2. When RH2 changes, VCE changes as well as IC changes. See this. Vary the VCE by adjusting RH2. Note down the readings of corrector current IC. So when you are changing IC, RH2, then VC changes, IC changes. Now note down these values. Now add these values. Now change RH2. Draw the graph. So this is for one fixed value of IB. Similarly, you can also change one more value, fix IB at different value. Take a 20 microamperes. And now change this resistor to, that is resistor 2, and find the VC as well as IC. Like this. So for different fixed values of IB, you can draw the graph. Now in this, any doubt?
No, sir.
The students. These are the input and output characteristics of C configuration. Any doubt in this?
No, sir.
Boys and girls, please respond, ma.
No, sir.
No, sir.
No, sir.
No, sir.
So you will be given 1.5 hour time. So in this 1.5 hour, you have to take 2 A4 size papers and that write the title, your roll number, name of the students, roll number of the student, as well as aim, first experiment name and the title, name of the, that is aim of the experiment, operators, procedure, and if there are any calculations, and expected graphs, circuit diagram as well as expected graph. You have to draw all this one in these 2 white papers. Along with that white papers, so after writing this expected graphs, procedure, and the aim, uh, calculations, etc. Now take that as, or convert that as PDF format by scanning that one. Are you getting this one, ma? Are you following me?
Sir, repeat one, sir.
Yes. So along with this printout, we had to take 2 A4 size papers. In that A4 size papers, so whatever do in your laboratory, regular laboratory. So in the regular laboratory, in the observation, you have written the title of the experiment as well as aim, procedure, circuit diagram, expected graph. Now we have to draw all this one in A4 size papers. After writing this procedure, circuit diagram, calculations, and expected graph on A4 size white papers, now take that, scan that by using your mobile and convert into PDF format.
So how we should send, sir, in WhatsApp or in laptop?
No. I will. First, you are following this one. After converting PDF format, that PDF format as well as this printout is there now. You are doing experiment in this simulation now. Yes.
Yes, sir.
So these two, this printout as well as your converted PDF, which you have written in A4 size papers, the 2 documents would be sent to me by email, or I will inform you later by email or by attaching through the Google form. You are writing physics examination na? Like that I will give an option, or otherwise you can send me through mail, no problem. But we have sent that all these documents within 1.5 hour time only. After 1.5 hour, I won't accept that. Are you getting this?
Yes,
Yes,
sir.
sir.
Any
Sir,
doubt in
theory,
this?
sir.
Sir.
Theory not required.
Okay, sir.
Only aim, operators, procedure, if there are any calculations, and circuit diagram, expected graphs. That's it. Till now, any doubt? Dear students,
Sir,
No,
any
sir.
precautions result, sir?
yes?
Precautions result atla.
Result is must and should not. Last, finally,
Precautions
result
of.
is, because it's not required. Result is compulsory.
Okay, sir.
I am once again repeating that for result only we'll give some marks. We award some marks. If there is result, then only we understood that you are completed the total experiment. Result is must and should.
Okay, sir.
Next, any doubt?
సార్ ఇప్పుడు పీడిఎఫ్ లో ఒక గ్రాఫ్ ప్లాట్ అయి ఉంటది కదా సార్
1 minute, ma. 1 minute. Wait for 5 minutes.